Welcome to COM 320, Advanced Audio Production. My name is Justin Krakey, and this lesson is about the physics of sound waves. The sound wave acts very much like waves in water. Sound occurs when vibrations cause the surrounding molecules in a liquid, solid, or gas to vibrate as well. The energy from these vibrations moves through the medium in a longitudinal or wave-like manner. This is possible because of the medium's elasticity, or how the molecules tend to return to their original position after the vibration displaced them. As a vibration moves outward through the medium, it pushes the molecules against each other, creating compression. Then as the vibration moves inward again, it pulls the molecules further apart, creating what is called a rarefaction. The number of times the vibration completes one compression-rarefaction cycle each second is how we measure the frequency of a wave. This is expressed in cycles per second, or hertz. So something that is vibrating at 440 cycles per second would have a frequency of 440 hertz. We perceive the sound's frequencies, relative highness or lowness, as pitch. The faster the vibrations, the higher the pitch. Frequencies that have a tonal ratio of 2 to 1 are called octaves of each other. For instance, 110 Hz to 220 Hz, or 220 Hz to 440 Hz, and 440 Hz to 880 Hz. These octaves are also known as the pitch of A. Humans can typically hear a range of frequencies from 20 Hz to 20,000 Hz, or 20 kHz. This frequency spectrum is divided into 5 ranges based on octaves. The low bass, or 20 to 80 Hz, is octaves 1 and 2. The upper bass, 80 Hz to 320 Hz, is octaves 3 and 4. The mid-range is 320 to 2,560 Hz, and these are octaves 5, 6, and 7. Upper mid-range, 2,560 Hz to 5,120 Hz, is the 8th octave. The treble range is 5,120 Hz all the way up to 20,000 Hz, and these consist of octaves 9 and 10. The intensity of the vibration, or the amount of molecules displaced throughout a cycle, is called amplitude. This is perceived as the sound's loudness or softness. Amplitude is measured in decibels. A decibel is 1/10 the measurement of a bell, and a bell was the value used to measure the amount of telephone line signal dropped over the distance of a mile, and is named after Bell Systems founder Alexander Graham Bell. Sound pressure levels are used to measure the atmospheric pressure of a sound wave. Humans can hear a range from 0 decibels sound pressure level, the threshold of hearing, to 120 decibels sound pressure level, which is the threshold of feeling. This continues to 140 decibels sound pressure level, which is the threshold of pain. This decibel range between the loudest and softest sounds is called the dynamic range. Sound's velocity through air is 1,130 feet per second at sea level and 70 degrees Fahrenheit. Sound travels 4,800 feet per second in water. The denser the medium, the faster sound can travel. The distance sound travels over one cycle is called its wavelength. Frequency and wavelength are inversely proportionate, meaning that the lower frequencies have longer wavelengths and higher frequencies have shorter wavelengths. The pitch of A, that has a frequency of 440 Hz, has a wavelength of 2.5 feet. The next higher octave of A, that has a frequency of 880 Hz, has a wavelength of 1 1/4 feet. A lower pitch A, with a frequency of 110 Hz, has a wavelength of over 10 feet. When waves are traveling on the ocean, the power of one wave can add or subtract from the power of another. The same thing happens with sound waves. This is known as acoustical phase. Sound waves that are in phase will have a resulting wave that is twice the amplitude. Waves that are out of phase cancel each other out. Thank you for joining me in this lesson about the physics of sound waves.